Hello and welcome back to your discussion of rocks and minerals, earth materials. This topic we're going to cover is called the rock cycle, and it is one of several cyclical processes that are occurring on the earth or within the earth or some combination thereof, in which materials exchange between different kinds of reservoirs. In this case, rocks, the three main kinds of rocks, sedimentary, igneous, and metamorphic rocks, are the reservoirs themselves, and they exist in different environments. There are different processes that change or move those rocks. And then there are the overarching processes that drive the cycle itself. In some cases, it's chemical reactions, an exchange, equilibrium balance. So, for instance, the nitrogen cycle, the carbon cycle. Right? These things are driven by pressure, temperature changes, decomposition of materials. In the case of the rock cycle, the sources of energy that drive the changes in the rock cycle come from two different places. One is Earth's interior, and the other is the sun. Okay. If we take the three different kinds of rocks that are part of the cycle, we have metamorphic rocks. I'll just label them. It's amazing. I'll just go ahead and erase that. There we go. Metamorphic rocks, igneous rocks, sedimentary rocks. The rock cycle involves changing one rock into another rock. So if we want to take a metamorphic rock, we can start there. We can drive it to create an igneous rock by melting it. Okay. That melt will then crystallize. It's a process that forms an igneous rock. Okay. If we want to take the igneous rock and make a sedimentary rock, we need to bring it to the Earth's surface. We need to cause weathering, break it down into sediments. Those sediments get collected and lithified, that's another process, to make a sedimentary rock. If we want to make a metamorphic rock, we can take those sediments and subject them to higher pressures. I'm just going to label this as P and T, pressures and temperatures. And we can create a foliation and deform the rock and create a metamorphic rock. Now, the cycle doesn't have to go in one direction. This sort of way of organizing it, it's sort of a counterclockwise flow. An igneous rock can go back and forth or directly back to metamorphic. Okay? We don't have to go onto weathering and sedimentation. The metamorphic rock never has to actually be melted. It can come back in this direction to create a smaller kind of loop, okay, between metamorphic and sedimentary. Cook the rock at higher elevated P and T and weather it at the Earth's surface. It's not very easy to go straight from a sedimentary rock to an igneous rock. Usually it goes metamorphic and then back to igneous. Okay. But you can create, the point is that you don't have to begin with a particular type of rock. You don't have to end with a particular type of rock. There's no mass loss in the system. This process just keeps going around and around. So we can look at the environments and where these things happen, right? Lots of stuff is happening down here in the Earth's interior where it's quite hot. Rocks and sediments get buried, pushed down into the Earth's interior, where they become metamorphic rocks. We may get them really hot, make them into magmas. Okay? Magmas rise up to the Earth's surface. They are subjected to weathering and erosion, okay? And that creates sediments and then brings them back into potentially becoming sedimentary rocks. And then sedimentary rocks can become metamorphic, or they could then just come back up to the Earth's surface like this. So this is the essence of the rock cycle. The question is what drives it, and the answer is tectonics. The cycle is driven forward, okay, one rock to the next, by tectonics, and tectonics drives Earth's interior heat, or is driven by Earth's interior heat. Okay? plates move because of more buoyant rock rising, moving out to the right, pulling one plate off to the right, or one plate off to the left. Right? Plates come together for the same reason, because of circulation in the Earth's interior and the mantle, and so it's tectonics that drives it, and tectonics is driven by temperature gradients in the Earth. It's very hot in the center, the core is cooler on the outside. The other component of this we have to factor in is weathering and erosion, and this energy comes from the sun. Okay? Less significant, it doesn't move the plates, but it does drive chemical reactions, it does drive the hydrologic cycle, which all work to weather and break down rocks. So in short, most of the energy for the rock cycle is produced in Earth's interior, but it is aided by energy from the sun, and the heat in Earth's interior is the byproduct of radioactive decay, the decay of potassium, uranium, and thorium. So in a sense, we have all these different kinds of rocks. They all make up the Earth's crust. The Earth's crust is made up primarily of silicate minerals, and those silicate minerals are constructed from bonds and atoms and things that we've already talked about earlier on. It's now time to kind of figure out, well, how does this affect us, or how do we affect it? In environmental geology, the door swings both ways. The Earth can affect us with its geologic hazards. We've chosen to live in certain places of the world or around areas that will create what we consider to be natural disasters. We also affect the Earth, digging into it, removing materials that we need from it, extracting them, depositing wastes in landfills. All of this is part of environmental geology. Alright, so we'll move on to some subsequent chapters dealing with things like volcanoes and earthquakes. That about does it for rocks.